So I want to ask you guys a question. What is your first ever gaming mouse? For me, it's the Razer Diamondback Plasma Limited Edition, and as you can expect of something like your first ever gaming mouse, it holds quite a bit of sentimental value to me. After all, I got this mouse just as I was in college nearly about 10 years ago. As you can expect of a mouse that is 10 years old, things have started to break down, and so I have repaired this mouse a couple of times, like replacing the micro switches on the left and right clicks, and of course the switches on the well, not the left and right clicks in this one, the side buttons, and the left and right clicks on the main body. As you can tell here, this one is white and that one is red because they have been replaced before. However, as you would have it when you're young and inexperienced, you can actually damage the board when you're doing these kinds of repairs, and let me show you what that looks like. As you can tell here, this solder pad has actually kind of peeled off the PCB, and this can happen when you overheat the solder pad. And yeah, when you overheat the solder pad, it has a tendency to just peel off the fiberglass of the PCB. Now, it is of course possible to repair this, and I have actually done this before on this joint right here, and well, these 4 joints and these 2 joints with this one left, because I'm going to show you guys how I do it. Now, this is by no means the best way to do it. It is just the way that I know how to do it, but you know what, I'm going to show you how I do it in this video while I bring together the first ever gaming mouse that I've ever owned back to life. First up, let's talk about the tools that I'm going to be using in this repair. I've got a tube of solder mask here that I got off Shopee in Malaysia, but you should be able to use just about whatever. Mine is pretty much the cheapest that I could find on there, and well, it works just fine. To cure the solder mask, you're going to need a UV light, and the one that I have here, this huge UV lamp, is actually used for mobile phone repairs, so it's going to be a bit overkill. I heard that you can use some flashlights or whatnot, and that can do the part, but bear in mind that if they're not strong enough or bright enough, they may take longer to cure the UV mask. I've also got some copper tape to replace the torn off and missing solder pads, a craft knife or hobby knife that I use to clean the existing PCB, some isopropyl alcohol, and some fine tipped tweezers. You're also going to need a soldering iron. The one that I have here in front of me is the Kasadi 936. That is a Hako clone. And of course, just as we have a soldering iron, we're going to need some solder as well. And to make my soldering job easier, I like to use some soldering paste Flux. This stuff makes solder flow like water, and I got this exact tin nearly about 10 years right about now, and I've still got so much left, so it's totally worth it. You probably don't even need to put a lot. I don't use a lot of it each time. Finally, since what I'm going to be working on is pretty microscopic, I have a digital microscope here with me, and you guys are pretty much going to be watching me from this perspective as I work on the board. To start off, what I do is clean the surface where the solder pad will be placed on. I do this with my craft knife and just scrape the surface of the fiberglass of any burnt materials that was there before until I'm happy with it. I also make sure to scrape off a bit of the solder mask on the existing solder traces to expose the copper beneath it, as this is where we'll connect our solder pad to. Once we're done, clean the surface with isopropyl alcohol and a cotton Q-tip and make sure it's nice and clean. I cut a small piece of my copper tape the size of my desired solder pad and then adhere that to the part of the board where I just cleaned. I like to make sure that the copper strip that I just cut is just ever so slightly longer than the copper trace so that it sits above it. I dab a bit of solder mask onto the palette here and try to cover the edges of the copper strip with the solder mask, except for the edge with the copper trace. Since working with this part is really microscopic, I'm just using the tip of my tweezers dipped in the solder mask to apply it. Once I'm happy with the application, I set the UV lamp on top of it for about 15 minutes. I found that 15 minutes works well for me to fully cure my solder mask. Again, depending on the strength of your UV light source, you're going to want to maybe put it for longer or shorter. We can tell that the solder mask has fully cured as it is no longer shiny but rather has a matte-like surface. It is time to join our new pad to the trace, so I dab a bit of flux onto the board, then heat up my soldering iron to about 300 degrees Celsius, touch a bit of solder onto the tip so that there's a tiny bead at the tip of my iron, then lightly touch the area between the copper tape and the trace to form a new solder joint there. The reason why I put the UV mask first is that the adhesive below the copper tape loses its stickiness with heat and has a much higher tendency to move and slide around. The solder mask helps to prevent that from happening. With a good joint now in place, I once again clean the area with some isopropyl alcohol and a cotton Q-tip, then continue with the solder mask, this time covering the joint that we just soldered on. I cure it once again with my UV lamp for about 15 minutes, and once that's done, I use my tweezers to poke a small hole in the center and use a small screwdriver to enlarge the hole. To finish off, I just make sure that the hole is nice and clear without any copper tape pieces in the way. And this is what it pretty much looks like with the repairs done. As you can tell, I've already soldered on the joints here, and yes, they work perfectly fine, so that is awesome. I've also done this same repair on the main board of the mouse with the left and right clicks because, as you can tell here, the solder pads have ripped, but this one was a little bit different because the traces for the left and right clicks don't actually exist on the bottom side of the board, but rather on the top. So what I had to do was cut a U-shaped kind of trace for the copper pad, wrap it around, bring it over here, go under the switch, and I soldered it onto one of the traces underneath there. Yeah, a little bit more complex. But another thing which I've done is actually I've replaced the direct pin connection, direct pin solder connection of the daughter board and the main board with some pin headers right there, so that the next time I have to repair this, I don't have to keep desoldering and resoldering this, which adds a lot of potential damage to these joints. And they are a bit fragile. So instead, what I can do is in the future, well, not in the future, like now, instead of having to solder it in, I can't see this, gosh, there we go. So it's gonna be something like that. There. It would fit right in and just pops right in, like so. And if I ever need to remove it, I can just, boop, just like that. I think the only thing left then is to put it all together, so let's go. So, minor setback. I tried to plug the mouse in, but there was no life coming out of the mouse, and so I panicked just a little until I noticed that some of the wires on the USB cable internal connector have also torn. Probably something that I should have expected from a mouse this old, but never mind. I see this as a good opportunity to change the cable to the braided cable from my also broken Roccat XTD. And so I designed and 3D printed a new replica cable stopper for my Diamondback that fits the thicker braided Roccat cable, slid it on, glued it in place, and migrated the internal connector of the Diamondback onto the Roccat cable. I put it together for the second time, and that new braided cable on my Diamondback is looking pretty spiffy. But most importantly, does it work? Yes, yes it does. All of the buttons are now working perfectly, and heck yeah, I love it when a repair comes together. Admittedly, not the easiest repair to do. In fact, I'm not even sure how many of you will attempt it. But hey, it's something that I had a lot of fun with, as it is a test of patience and skill, and nothing is more satisfying than seeing such an important memento of your life come back to life again. Yeah. I hope you guys found this video helpful. If you did, make sure to give it a like. If you've got any questions or suggestions, feel free to drop them down below. And if you'd like to see more reviews and repair videos from me, make sure that you're subscribed to my channel and notified with the bell icon for any future videos. Don't forget to also share this video as well if you think it's cool. Thank you so much for watching. My name is Yang, the Tech Rodent, and I absolutely love repairing stuff. Nothing is more satisfying than seeing stuff that is left for dead come back to life. I'll see you guys in the next video. Paul.